So, a very good afternoon to you all. And I welcome you to the session on image visualizations in Google Earth Engine. So, in today's session, we will see how do we search for some specific images of different satellites or different data which is available on Google Earth Engine, and we'll see how do we visualize those images maybe a single band image or a multi-band image. Then in the later part of the course, we will see how do we see some spectral reflectance curves of some specific features using Google Earth Engine. So, my today's lecture will be having we have two parts. In the first part, I will just briefly cover basics of remote sensing that we'll use for image visualization, and in the second part, we will see live demonstration how to do all this in Google using Google Earth Engine. So, what is remote sensing? So, as I think you must be familiar with these terms. Just for the people who are not familiar with these, I will just for the sake of those, I will just introduce you the basics of remote sensing. So, if you see the textbook definition of remote sensing, it says it's art and science of obtaining information about an object or the phenomena through analysis of the data that is obtained by a device that is not in contact with the object or phenomena, right? So it's all about collecting information about some object, any object or phenomena of your interest by not coming into direct contact of that object is all is called remote sensing. Like whatever we are seeing with our eyes, so we are not coming into the direct contact of the object which we are seeing. We are just remotely sensing that our eyes are remotely sensing that information, and our brain processes that information. Right. So similar way in the remote sensing, we have satellites orbiting around the Earth, so they take the images of Earth on the daily basis. So that is a remote sensing. So if you see, so finally, if you see an satellites will be capturing images. So digital images are made of pixels, and pixels ultimately are represented as a cell of or grid of cells. So and every cell will represent some value. So that value may be as a reflectance in some electromagnetic electromagnetic reflectance, maybe in some particular band, maybe band 1, band 2, band 3, or the pixel value may represent may say the temperature on the earth's surface, right? So I can say that images are made of pixels. So here you can see that this entire image is this is an image of some area on the earth, and if you zoom into this particular area, you will be seeing like this. So here there is a different cell values. So these cell values may represent any information. So that may be a temperature on that location on the earth, or it may be the reflectance in some electromagnetic band, EM band. So so the values, whatever the cell values, the values as the cell represents are the amount of reflected electromagnetic energy, right? So this may be represent some electromagnetic energy, amount of reflected electromagnetic energy which is everywhere, and everything reflects there or absorbs it differently and miserably. The sun is the source of that electromagnetic radiation, and all the features on the earth's surface will be reflecting some energy from that. So the sensor will be capturing that information, and that will be processed and will be displayed as an image. So the value of the energy reflected by a particular surface will be dependent on the different properties of that feature which we are looking at. So if you see the entire electromagnetic spectrum, so it covers from the gamma rays to the radio waves in the this is the range of this is the increasing range of decreasing range range of frequencies and increasing wavelength. With our eyes, we can see the small spectrum of this in the visible range, but we have satellite sensors which can capture the information. Some sensors can capture information maybe infrared or microwave wavelength as well. So if you see any satellite image, so satellite image can have one or more bands, right? So images are stored as what you can say as raster, and they can have one or more bands. So if you see some different terminologies are there. One something called panchromatic or monochromatic band. So that but those images have a single band, and the color images generally whatever we see as color images generally has more than one band. So basically they have three bands: one band red, green, and blue, and they mimic the way human eyes work. So spectral images, so we can say that there are two types of images, panchromatic or monochromatic images, or multispectral images. So panchromatic or monochromatic images will have just a single band, while the multispectral images have more than one band. So multispectral images can have even 3, 4, 5 or 6 bands. So out of these bands, we can select any 3 bands for visualization that can be represented as red, green or blue. So whenever we are displaying an image, suppose though our satellite sensor may capture images in maybe 6 bands, but out of these 6 bands we can select only 3 for the visualization because of the limitations of our display. So either of these 3 we can route to the red, green or blue channel, right? So this is, you can see that our satellite may be capturing information in 6 bands, but we can route any of these to the red, green or blue band to make a composite image. So this is called a false color composite. Right, so this we will see how do we do it in Google Earth Engine. So anyway, I think in the previous lecture it must have been covered. Just for the sake of completion, I will be cover like what is Google Earth Engine. So Google Earth Engine, you can say, is a geospatial processing service powered by the Google platform. It is a planetary scale platform for Earth science data and data analysis, data analytics, you can say. Plus, it combines a multi-petabyte catalog of satellite imagery and geospatial data sets with planetary scale analysis capabilities. So almost all of the geospatial data which is available on the open source is available on the Google Earth Engine for processing. It provides an interactive platform for geospatial algorithm development at scale. Actually, when you are working on maybe on your local workstation or system, you have a limited capabilities. Like you cannot, suppose if you want to do the analysis at the global scale, so that is not possible to do on a single workstation. So for that you need massive computational power and massive storage infrastructure. So Google Earth Engine offers you all this at the convenience of just you need to know just a basic commands. So Google Earth Engine is a big data analysis and visualization platform that is inherently parallel system. So there are a lot of systems working in parallelly for solving the problem. So this is the basic motto what they say, that it is designed for scientists, not for the software engineers specifically. So any person who doesn't have much experience in programming also can learn Google Earth Engine quite easily. So its goal was make it easy to enable non-traditional users, like to empower the non-traditional users for remote sensing application development. So the mainly Google Earth Engine is mainly focused on solving the society's big challenges like deforestation, drought, disaster, disease, climate change, conflict, global food security or sustainability. So this is these are the satellites, these are the data sets which are available from the Google Earth Engine, right from, so you can see that GPM, Landsat 8, Landsat 9, Sentinel 2, Sentinel 1. So any open source data, you name it, most of the data you will get on the Google Earth Engine by default. So if you want to know more about that, you can go to the Google Earth Engine's website, and they have the list of all the data sets which are available on their analysis platform. So what you can do with Google Earth Engine, as we have said that with the Google Earth Engine you can do analysis at the global scale quite easily. Like suppose if you want to create a mosaic of the entire Earth, so quite easily with just a few commands you can make that cloud free mosaic of the entire Earth quite easily using Google Earth Engine. Then suppose if you want to do some time lapse analysis, like you want to see how your region of interest or the geographical area which you are interested in, how it has evolved over the time, like how you want to do some time lapse analysis. So those things also can be done quite easily. The slides which I will be showing you here, I have just taken from the Google Earth Engine website. Like this, you can say that how the snow cover is changing over the time. Then you can see there how deforestation is taking place, or how the city is expanding, how the course of river is changing. So these types of time lapse analysis you can do quite easily using Google Earth Engine. So then this here you can see the expansion of city, deforestation. So this is the these are the this is how do you use the computation platform. Actually, there are two ways with which you can interact with the Google Earth Engine. Suppose you want to access some data, so there are two ways with which you can access the data on the Google Earth Engine. One is called on-the-fly computation. So here you can interactively visualize data. You can ask or queries to the Google Earth Engine and preview the analysis results interactively. Like in interactive mode, you send some you request some data to the Google Earth Engine, it provides you the data. You request some algorithm to be run on that data or some analysis to be done on the data interactively. You can ask through some APIs and it does the analysis and returns back you the result. Then another mode is called batch computation. Suppose if you want to do analysis for a large area or some very complex analysis you can do, so then the mode batch you can do avail the batch computation feature of Google Earth Engine as well. So this is the basic architecture of the Google Earth Engine APIs. So you can say that on the Google Cloud, all the data is stored in all these servers. Plus, Google Earth Engine provides different algorithms for working on that data. So a client or a user requests like whichever data it wants through some queries, then user can ask for applying some algorithmic primitives on that data, right? So then all these things will be done on the Google server, and finally it will return you a result which you can visualize on your browser. So this is the basic computation or service architecture of the Google Earth Engine. So you need to just request for the data using some primitives, and the data actually is residing on the Google Cloud, and it will be fetching the data from the different servers, and then you can ask for applying some primitives on that data, algorithmic primitives, and ultimately it returns you the result which you can visualize on your browser. So for today's demonstration, we will be using something called Google Code Editor. So Google Code Editor is an integrated development environment for writing Google Earth Engine codes. So anyway, we will be showing this. In this, you can write your code, visualize the code. You can access the documentation available with Google Earth Engine and many more. You can create maps, charts, and all things. You can see the outputs on the console. You have help button. You can inspect, import additional things. Plus, you get access to the all API documentations. You can create apps also from this code editor itself. So how to use Google Earth Engine? Actually, there are two ways to connect to this. So connect to the Google Earth Engine service through one of the APIs. So basic, as we said that you need to request. Suppose if you want to access some data, so for that you need to request the Google server for that particular data. So how do we access that data? So the data can be accessed using some APIs, right? Plus there are some client libraries. Google Earth Engine offers APIs in JavaScript, Python, and REST-based APIs for accessing the data. So for our demonstration, we will be using JavaScript APIs for using Google Earth Engine services. So this was all about this. Now let us see how do we access these APIs. So for that, I think it must have been told to you yesterday. For accessing Google Earth Engine, first you need to request for the Google Earth Engine account. So with your Gmail account, you can just request Google Earth Engine access. Once Google approves your request, then just you can log into this code.earthengine.google.com and access. So code.earthengine.google.com. I think I have already. So once you log in here, so I think in yesterday's lecture you must have already been got familiarized with this construct. So this is the code editor's main interface. So this is the code area where we will be writing the actual JavaScript code for requesting data from the Google Earth Engine. And on the left hand, you can create different this is the file editor. You can create new scripts and save those scripts. And in the docs portion, you can access the documentation, like like which are functions are available, like e.image and whatever. So this is the entire documentation about the Google Earth Engine. So this is the area where you can, this is the console output, and this is the inspector where you can inspect the output of commands interactively. And they are actually, when we are running, as we said, that when we are you want to run something on the uh, batch mode, so here you will be seeing the tasks. So anyway, right. So before going too deep into the Google Earth Engine analysis, so I will first introduce you some basic terminologies that we'll be using in this. Actually, for the sake of easiness, actually I have written all this code in a notepad, and I will be copying the code which is required for demonstration one by one into the code editor, and and explaining that code and running one by one. So basically, if you see the Earth Engine's data structure, so all basically there are two fundamental geographic data structures in Earth Engine. So images, one is image, or image, all the raster data is represented as an image, and all vector data is represented as something called feature. So images are composed of bands and a dictionary of properties that define those properties of that image, like how many bands that particular image have, what is the projection system, what is the scale of image, and like that. Then features or vector data are composed of geometry and a dictionary of properties describing that geometries. Then another data, like, so these are two basic construct, image and feature. Image is all the raster data. Raster data is represented as an image, and all the vector data is represented as feature. Then a stack of images. Stack of images is called image collection. Similarly, a collection of features is called feature collection. Then other important data structures are like arrays, chart, dictionary, list, arrays, and anyway we will not be discussing all about this. So basically we will be dealing today just about image and image collection. So image is just any raster data is represented as image, and a stack of images is called an image collection. So as we do in any programming language, so first thing we do is called printing the hello world. So suppose if you want to print hello world on the Google Earth Engine's console, so this is the console. So the command you need to write like print hello world. So if you just write print hello world and click on run, you can see the hello world message printed on the console. Here you can see that. Something got printed on the console. So similar way, now suppose if you want to create some variables in JavaScript. So creating variables is also quite simple in JavaScript. So you can for creating a variable, you need to specify like where and the name of your variable, and in that what kind of value you want to store. Like suppose if you want to store a string value inside your variable, then in a single quotes you can put your string. Then similarly, suppose if you want to store a number inside your variable, then you can say where number equal to and specify the number. And finally, suppose if you want to print the value of those variables, you can say print the name of variable. Now if I run this code, you will be seeing here hello world, then the value of the green string variable, hi Google Earth Engine, and the answer is number. So if I run here, you can see on the console there are three outputs: hello world, hi Google Earth Engine. We have printed the second variable green string, and third variable number. Right, so this is how to create variables. So these variables only will be using on our program. So next part, let us see how do we load an image. Because as we have seen that Google Earth Engine, if you see the Google Earth Engine data catalog, If you search Google Earth Engine data catalog on the browser, you will see here. So these all data sets are available on that, on the Google Earth Engine. Now suppose if you are interested in Landsat 8 images or Sentinel images. So let us see how do we load images on the map for analysis. So I'll be just taking this. Right, so as we have said that raster data are represented, raster or any raster data are represented as image object in the Earth Engine. So images are composed of maybe one or more bands, and each band you can say has its own name, data type, projection system, and other things. Right, so all raster data are represented as images. Then scale, mask, projection, and each image will have each image apart from this, each image will have some metadata also stored with that image, like when the image was acquired, what area it covers, and so on. So for loading an image on the Google Earth Engine, first we need to call this constructor called ee.image. So ee.image, and to this image constructor we need to pass a string defining the name of the image which you want to access, right? So first ee.image and the name of image. Now the question comes, how do we know the name of image which we want to display on the map, right? So either you can get the name of image from the catalog, Google Earth Engine catalog, which I showed you there, or you can search on the search button. Like suppose if I want to see the SRTM DEM, so I can search for SRTM digital elevation data version 4. So either I can search for the image ID on the search panel, or maybe I can open the data catalog, or from there I get. So if I just click on this SRTM digital elevation data version 4, then I get the description of the image here. Like it says ee.image, so this is the image ID. Plus there are examples on this, and you get to know about the description of this particular image. Like you can read about this, what this particular image represents, terms of use and citations, right? So for getting, this is the way how do we get the name or image ID, right? So I have copied this. So once I have so what is this? This is ee.image is called a server object. Actually what happens, this object is actually residing at the Google Earth cloud. So it is not existing at our local browser. So there are two types of objects whenever you are writing the script in Google Earth Engine scripts. One is called client side objects, or another are called server side objects. So client objects are the objects which are existing at your browser's memory, and the server side objects are the objects which are residing at the Google's Google Earth cloud. And this ee.image or ee.something is called the container for that. So this container will be carrying the information from the server to the client for displaying. So once we loaded an image by calling ee.image and passing it the image ID, then we suppose if you want to load it on the map. So by default in the Google code editor there is inbuilt map. So first thing what we are doing, we are setting the center of the map. Like whenever we first time the map gets displayed, we want to set the map to be centered at this particular longitude and latitude. So for loading an image, first we need to set map.setCenter. Like when the map starts, the map should be centered at this location, lat long, and the map, or what you can say, zoom level. So as you increase the level of zoom, you will be seeing the smaller areas. Like if you see, we are seeing at zoom level 2. Now you will see the entire Earth. So similarly, if you see at zoom level 10, you will be seeing that small specific area but at higher resolution. So, so here we are doing three things. First, we are loading an image by calling ee.image. Then setting the center of the map, like when the map opens, the map should be centered at this longitude and latitude, and you are specifying it 3 parameters: longitude, latitude, and the zoom level. And finally, we need to add this image to the map for visualization, like map dot add layer, and we pass it the image. Now if I run this piece of code by clicking on the run, you can see that map got centered somewhere here, and a layer got loaded into this, right? Layer 1 with the layer, and there are certain parameters, we can change the name of this layer and so on, right? So this is, we can say that we have seen the entire SRTM data for the entire earth. Thus by writing a single or two or three commands, we could visualize the entire SRTM data in a single click. Otherwise, suppose if you have downloaded SRTM data before, then you need to download it in the tiles, then merge in tiles, but using Google Earth, and just with a few commands you can load the entire data. Now as you can see that the visualization is not good, because the color scheme whatever we have used is not quite good, and the range of numbers also may not be appropriate for this entire range. So for that we need to specify the range. Suppose if you want to change the visualization of this particular image, so there are multiple ways, right? So first thing is for changing the visualization. Now first thing, suppose if you want to change the min and max, like the values to be displayed in this particular range. So for that there is something called inspector. So there this can be done in two ways. So right, so first for that, suppose if you want to know the min and max values in this particular image, so some data you will see in the documentation as well. Now suppose if you want to explore yourself, like in what range the pixel values or elevation is lying. So what you can do for that, you can just click on the inspector and click on any area there. So if I click on this area, so then you can see that the inspector lists like so if I click on this, so it is at this particular location. So this is the point 77.28 and 39.19. The elevation, the value of elevation is 1117. Then I can click on here. It says at this location the elevation is 187. And if I go to this area, it says if I say go near sea level, you'll be seeing this area is masked and 278 and so on. So by looking around the images, you can just get a feel of the values in which range they are lying. But when you are seeing at the global scale, it becomes quite difficult. So right, so for that there is another way for getting the max and min values. So for that you can go to the layers and click on the setting, this gear icon here, right? So by default it shows that it is using this range for showing the data max and min. Then you can click on the custom. Now suppose this is default, like suppose if you want to stretch to 98%, like all values you want to stretch to the 98th percentile. So then you can just click on 98th percentile and you will be getting two values here. Like with this you will get the modified range, like 78.44 to 5235, and you can just say apply. So now you can see that the image visualization gets changed, right? So similarly you can change another ranges, like you can stretch to the 1 sigma, 2 sigma, 3 sigma, or you can change the gamma values, you can change right? So then you can change to stretch to 1 sigma, 2 sigma and 3 sigma. So by doing these different experiments, you can get the best values for your application, like whatever values best suit to your requirements, those values you can select from here. Like suppose if by default, suppose we assume that we have selected, see these things you can do it after loading the image also, but when you are doing some thing automatically, so in that case you cannot just go to the screen and select these parameters and do that. So suppose if you all these things you want to do in a script, so for that now suppose you have decided that you want to display you want to show the pixel values in the range say 0 to 3000 or 0 to 4000 or whatever you have selected from this list, like say stretch to 3 sigma, and now you can see that the range has changed from -2564 to 4386 or whatever you choose. So then suppose if you want to select that, then you can specify while adding this particular image to the map, you can specify these limits as well. right? These limits go when you close the image. Like now what I am doing here, I am adding the like same image I am adding. I am to the add layer. I am passing now another argument, another argument in the form of a dictionary, right? So it's the same function now map dot add layer. In the first case, I just passed it a single argument called image, which I wanted to display. Now in the second case, I am passing it three arguments. Like first the image which I want to load on the map, then the min and max values to be used for visualization. Like just show the values in range 0 to 3000, and I just wanted to give it the name of the visualization. Like I'm saying it, I want to the name layer to be named as custom visualization, so that you can easily identify. Now so if I run this piece of code, you can see now that there are two layers are added on the map. One is custom visualization and layer 1. Now you can see that now if I now you can see, this way we can change the visualization of single band images. Now if you want to switch on or switch off some particular image, you can just click on this. This way you can change the visualization. So there are many more parameters which you can pass it. Now suppose if you want to so instead of showing this grayscale image, suppose if you want to show this image with some color palette, right? So then you can pass a color palette also to our map.addLayer function. So now here I have passed map.addLayer, then same image, then my min and max parameters, and the color palette to be used for visualization. Like if I just wanted to display this these pixel values in using three colors, maybe say blue, green, and red. So then we can say pass and third argument, second argument to this visualization, like min, max, and color palette. And now if I run this piece code, now we will have see three layers added to our map. So one is layer 1, then custom visualization and custom palette. So here now we can say that by passing a color palette, we can change the visualization of our image to any whatever color palette we want to use for visualization. Right, palette blue, green, and red. So this way we can change the visualization of our image. You can specify. Then there are many more parameters. You can go through the documentation. You can change gamma and other things. So this was all for single band image. Now suppose if you want to display a RGB composite or colored image, as we have said that satellite images may contain multiple bands. Maybe some satellite images may contain 7 or 8 bands. But for displaying it on a monitor, we need to select just 3 bands. So one of them can be represented as red, one of the another goes to the green, and third one goes to the blue. So this way we can create a RGB composite. So for loading a RGB composite also the same thing is there. So suppose now let us visualize a Landsat image. Right, so for getting the image ID, similar way you can get the image ID as we have got for the Landsat, SRTM image. Similar way we get it for a Landsat also, the image ID. Now suppose let's see how to visualize a Landsat 8 image. So this also the thing is same only, e.image, the image ID, whatever you either you get it from there or you get from the image collection. We will see how to. Then we are specifying here a dictionary or object called visualization parameters, as we have defined previously. There we were just passing directly this visualization parameter as a dictionary directly to our map.add layer, but here we are defining a visualization parameter object actually in terms of JavaScript, like visualization parameters. And here we are specifying, suppose there, because our previous image was having a single band, but in our case now our image has some maybe 5 or 6 band, but out of that 5 or 6 band we need to select any 3 bands for visualization, right? So we are selecting here bands 5, 4, and 3. These I think are the NIR red and green bands. Then we can specify min and max values. Then other things are same, map.setCenter and map.addLayer. So only additional parameters we have passed here, bands, which 3 bands you want to visualize. Now if I run this, you will see a Landsat image here. So actually I think I have not set the location correctly. So if I see, so this is 77.8. So now if I run, now you can see that we can, this way we can visualize, like, because Landsat 8 has 8 or 9 bands. So out of these, which 3 bands you want to use for visualization. Similarly, now suppose if you want to see the colored image, now I think this you can change to B4, B3 and B2. So if you want to see the true color image, so this way you can see a true color image. Then same parameters, now suppose if you see, click on this, so from here also you can change, like suppose if you see that the contrast of image is not so good, then you can stretch it to any of the combination and see the image. Now you can see that slightly the appearance of the image got slightly changed. Right, so similar way if I change, so either you can change from here, or suppose if you want to do it through script, then 5, 4, 3, and then you can apply gamma factors. So as say I'll stretch it to 3 sigma, you can see the image. Right, so this way we can visualize a multi-band image. So whichever band you want to select for red, green or blue combination for creating a false color composite, either you can specify them on the script part here using bands parameter, or directly on the user interface as well. So these are 2 ways with which you can do. So this way we can visualize single or multi-band images. Right, now suppose if you want to see, attach a color palette to some image, as we have seen in the previous case as well. So here I will just calculate an NDVI and attach a NDVI color palette. Now from the same image we will calculate something called NDVI and so as we said that initially, actually in the previous example, we said that when we were defining color palette, we defined the name of the color. So either name of the color you can specify as a text string, or you can specify the HTML code, hexadecimal HTML code for your color coding as well. Like suppose if we want to calculate the NDVI from this Landsat image. So actually image I have skipped. So image e.image. So for this I am calculating first NDVI. So NDVI is you can say the normalized difference between band 5 and band 4. So image e.image our image, and we are calculating NDVI calling image dot normalized difference and band 5 and band 4. And then for visualization we have defined the NDVI visualization object. In that we have specified the color palette, and the values of the color for the different ranges are defined using their hexadecimal code. Now if I run this, so I have not specified it to be true, actually whether to load it or not. So if say true, so this way you can say that you can specify the color palette on the fly. You can calculate the NDVI for your image, and using a color palette you can display the image. Right, so Then suppose if you want to get some metadata about your data, so either there are multiple ways for that. So basic information you can get about your image. So if you just say print image, so you get basic information about image on the console. And so you can say that this is image Landsat 8 image, and it says that there are 17 bands available to this image and the other properties. So this is just for display. Now suppose these properties you want to access in your code, right? So sometimes you may, depending on what are these parameters, depending on that you want to change the flow of your code. Suppose if you want to access these properties programmatically or in your script. So for that there are different functions available. So that also you can use for extracting the metadata from your image. So like so suppose if you want to fetch then what are the band names in your image. So in your image you can call the function image dot band names. Then suppose if you want to select some particular band and fetch the projection of that particular band, then you can say that your image dot select name of the band dot projection, scale, a nominal scale, then number, any other thing. Like there are different parameters. Then suppose if you want to know, get the timestamp where the image was acquired. So image dot get system time start. So if I run this, you will be seeing this a lot of outputs on the console. Like here you say that name of the image, these are the band names, projection, scale of the band is this is at 30 meter scale, then band date is at 15 meter scales, then other metadata properties, then version, date, timestamp, and other information. Like by image dot get which particular property you want to access, you can access the all metadata of your image by using this function. So now as we discussed that there is another data structure in Google Earth Engine, that is called image collection or a stack of images. You can say that if you refer to a particular image captured by satellite on some particular day, that is called an image. When you say that all images captured by actually for the ease of analysis, what happens, all images captured by a particular satellite are stored in something called the image collection. Image collection is a stack of images, like all images acquired by Sentinel-2 satellite are stored in an image collection called Sentinel-2 image collection. So let us see how do we access an image collection. So for knowing the name of image collection, so either you can search here like Sentinel-2. If I say so, here you can say that Sentinel-2, if we see Sentinel-2 MSI, and if you see here, so this is the Sentinel-2 image collection. So this image Sentinel-2 image collection contains all the images which have been acquired by the Sentinel-2 satellite over its lifetime. So from there you will get the image collection ID. So that we need to so either you can import, or anyway I already know. So similar to image, now we need to call image collection. So this is the name of the image collection which I will be acquiring. So instead of I will be using not acquiring. So instead of so I will call the S2 call. Okay, anyway. So I will call it image collection. Right, so image collection, I need to pass it the name image collection ID. Then what happens, actually you can see that the image collection, this particular image collection contains all the images of Sentinel-2, all the images which Sentinel-2 has acquired over its operating time, right? But because you may be interested in some images which were acquired during certain time period, or acquired for certain specific area. So what we need to do, because you are not we, because if you are, because we may not be interested in the entire image collection, we may be just interested in some particular subset of that entire collection. So for accessing or for accessing those particular images, which particular images of our interest, we need to filter our image collection. For filtering an image collection, Google Earth Engine provides a lot of functions for filtering an image collection by depending on what basis you want to filter it. Now suppose if we want to filter the images temporally, right? Suppose if you are interested in images which were acquired from 2000 for year 2022, assume that. So for that, now once we get the image collection, on that we need to call the function called dot filter date. So it will just, so image collection will contain all the images. So with the filter date, we can filter the images from our starting date to ending date, right? So this filter date will, from that entire collection, will just extract the images which were acquired during year 2022. So like starting from 1/1/2022 to 31 1, you can say 23, or 31/1/22 itself you can say. Or this is just for a month. Suppose if you want to do it for entire year, you can say 31/12/31, right? Then this is temporal filtering. Similarly, suppose if you want to filter the images, filter the image collection, you want to access the images which were for that particular area. So you want to filter images spatially. So then you can call the another function called filter bounds. So there you can specify the geometry, like geometry, maybe it may be a point or a polygon. So all the images which are intersecting with this geometry will only just be filtered out. Like suppose if you are interested in some particular city, then you can draw a polygon around that and filter by that spatial extents. Then suppose then you want to filter them by say by cloud cover, like you want just to filter the images which have less than 20% cloud cover, right? So then you can filter cloud pixel percentage less than 20. Right now we will not see this map.mask clouds. This is another function. So if I just run this, and if I just print this on the console, so now you can say that this particular this band, so out of this it acquired almost, so from the entire image collection it just filtered these 79 images. So like there are these 79 images which fulfill our filtering criterias. Right now suppose if you want to search for the images of your area of interest, like you can draw a polygon around your area. Like suppose if I want to access so let us first visualize the images, then we will filter it spatially once again. So there is another function called like these images. Suppose if you want to remove the or mask the cloud cover from your image, so this is a function called mask s2 clouds. Actually that this function you will directly get in the documentation of this. So actually with the all Sentinel-2 images, so Copernicus gives you another band called QA60. So this is just for masking the pixels which has cloud. So this function directly you can right now we need not pay attention to this particular function, this mask.s2 cloud. This function, what it does, it masks all the pixels by using this QA60 band. It masks all the pixels which have cloud in this image, right? Then it is just masking that image. So there is a function called map. So now suppose if you want to apply this mask s2 cloud function to all images in our image collection, then you can call map then mask s2 cloud. So this will apply this function on the all images on this entire image collection. Now suppose if you want to display this image, so we need to first specify these visualization parameters. Visualization parameters, like suppose if you want to visualize band 4, band 3 and band 2, and because this is this is an entire image collection. And if you want to see or reduce them to a single image, so then we can call as to our collection dot mean. So it will create a mean composite of these all images. If we run this, now you can see that these all images have been combined. Now if I don't call this mean function, then you may see slightly different. So this way we can visualize an entire image collection. Then if you find that the visualization is not good, then you can change from here. Say by default we will stress to 98th percentile, and now you can see the image. Now suppose if you are interested, you want to fetch the images for some different area, like suppose if I am interested in this particular area. So what I need to do, I need to first draw a polygon around this area, right? So I will click on the left side, there is a toolbox for drawing the polygons and other things. So I will just draw a polygon there. So you can say that a geometry gets created here. So I will do this and I will say that I will call it AOI. Maybe I'll just do it as geometry only. Okay. So a geometry gets imported here, AOI. So now what I will do, I will now instead of by, I will call filter bounds by AOI. Right now if I run this, then it will just fetch the images which are intersecting with this area. Now you can see that all the images which are intersecting with the polygon which I have drawn. So this way you can especially filter the images of your area of interest, right? So this way you can filter an image collection. So then then the second part, what we said, that now let us see how do we see the spectral response of these. Suppose if you want to see the spectral response of certain features, so then one thing you can do it directly, you can see the spectral response on the inspector module itself. Like suppose if because this particular image has more than many bands, so what I will do, I will just select few bands. I will remove this QA and other bands. So I will just then I will call this So what I have done, I have just selected these bands. Like this particular image was showing that 17 bands. Out of that I have just selected band 1, band 2, band 3, band 4 and band 5. Now if I run this, now you can see, now I'll change. Now suppose if I see a false color composite of this image. So band 8 is 4 and 3, apply. Stress to 2 sigma, apply. Now suppose if I want to see the spectral signature of say a vegetation area, right? So if I click on the inspector and if I click anywhere here and I expand the inspector, and it shows the values in for this particular point in all different bands. And if I want to see the curve, I can see like this as well. So this way you can see the spectral response of this particular picture. Similar way, now suppose if I click on a water body, the curve will change. So if I click on the water, it will draw the spectral response curve for the water. Now you can see that in these bands it is like this. The spectral response curve has changed. This has been shown as a bar chart. Now suppose, and this is just showing for a pixel, but generally when you do analysis, what we do the analysis for an area, right? We will be doing the average for some set of pixels. Not will not decide based on the value of a single pixel. So when let us see how do we do it using it for an area, right? So for that, first we need to define our areas as polygons, right? So first this we have done for pixels. Now suppose if we want to do for an area, like so first I will draw a polygon around this area. Now suppose I want to see the spectral response of a water body. So what I will do, I will go here. Now suppose I want to see the spectral response of two features in a single chart. So these things, this was shown as a bar chart. Now I want to see it as a line chart. So for that, first we need to draw a polygon for around our area of interest. Like suppose if you want to see around this area, so then you click on here. Sorry, exit. I will first click a new layer, and draw a polygon around this area. Like suppose if I want to do average for this area, right? So I will click on geometry. I want to say it at water. I will say water, and I will import it as, instead of geometry, I will import it as a feature. And property, I just want to add a property to this. I will say that this is class. I will say class is, I'll say it is water. Then similarly, I will click on some area where there is vegetation. So I hope that this is a vegetation area. I will click on new layer, draw a polygon around this. I will call this forest. Then as feature, not feature collection, feature, property, class, forest. Okay, now I have created two features here. One has water and forest. Now I want to see their spectral response in all these 8 or 9 bands, whatever I have selected here, in a single chart. Right. So for that there is in UI there is something called chart. So UI, you click on UI and UI.chart, UI.chart dot image region, UI.chart.image dot regions. If you call this function UI.chart.image dot regions, then it expects these arguments like image for which, from which image you want to create a spectral response curve, you can say, and the regions. Regions means all feature collections for which you want to calculate the average of that. Like for these reasons, like we want to calculate the see the spectral response for these two regions. So you can specify the regions, then a reducer, like how to aggregate all the pixels in this particular area. So there may be multiple ways to aggregate these regions. You may calculate the mean of these area, you can calculate max, or you can calculate the sum of all the pixels in these area, right? So the natural is mean. So we will create a reducer called mean. Then you can select the scale and the property with which you want to name the chart, and you can attach the label as well. So now I will take the code from here. So first I need to create a feature collection. So I will call here FC. So anyway, I have already here code ready with me. FC equal to e dot feature collection. So I'll call where FC is equal to e dot feature collection, water and forest. W is forest. WATRE it has become. WATRE. And if I run this and see, it is okay. So I have created a feature collection. Now I need to call the function called chart. So that helps me in creating a chart. So as I explained that for creating a chart, I will be using the function called ui.chart.image.regions. You can go through the documentation here. So it expects these arguments like your image from which you want to create a chart. Like our image is S2 collection S2COLL. So I am reducing these all images by calculating the mean of all the pixel in this. So S2 called dot mean. Then I need to specify the regions for which I want to create the chart. Like I want to create the chart for these by combining these two regions, one for this and another chart for this region, right? So by merging these two features, I have created a feature collection already. I have created a feature collection here, mean, and then how do I want to calculate the values for this entire region by using which reducer? Like this entire area I want to represent it. I want to calculate the mean of all the pixels which are lying in this region. So I have called the reducer called reducer dot mean, and at what scale I want to do the reducing. So I just want to see it at 10 meter scale because the Sentinel-2's native resolution is at 10 meter. I have specified as 10, and the label to be used for the feature is class. Now if I do this and print this chart, and if I run this, now you can see that on the console we got, but the label it has not displayed. Class, small class. So here you can see that water and another is undefined forest. It has become actually capital class. So this way you can see that these are the spectral or you can click on this and create a see the spectral response curves of this. Then you can do it for any other. You can see the spectral response for any other reason by adding a new geometry to your feature collection. Right. So this way we can create a spectral response curve for any feature of in our area of interest. Right. So with that we come to the end of this session.